Hello and good evening, everyone. Welcome to this one-off session or impromptu session of geometry, cosmology, spirituality. This is for the Mercury inferior solar conjunction, which is due to happen in about just under a quarter of an hour from now. Um, Over this past weekend, there's been various events here in the city of Wales, including one on Saturday evening for the Venus inferior conjunction. Very interesting time cosmologically at the moment, and um, uh, we processed around the cathedral singing a Marian chant. It was a really wonderful event, and I was teaching a course about the symbolism of the rose as well. But now for today, we'll look at Mercury and some of what Mercury shows us about geometry, cosmology, and spirituality. Right, so as you can see, here is an image of the planets orbiting the sun, and this is how this is actually how they were a few days ago, about 4 days ago, on the actual equinox on March the 20th. Now, let's just take a close-up look at those inner planets, because this is what's happening at the moment. It's a very interesting set of conjunctions. So this, as you can see from the date at the top written in green, this was the 20th of March, which was the spring equinox on Thursday. Now, if we go one more day forward, if you look at the planets, you'll see them move a little bit. So that was the 21st on Friday. And then if you look at the planets again, there they are, getting closer and closer to that alignment. Now, this is actually just before the Venus alignment happened. That happened around about 1 o'clock in the morning on the 23rd. So that's where we are yesterday. And then today, the 24th, it's Mercury that is in that conjunction. So we have pretty much a straight line between us on planet Earth, Venus, the planet of love, and Mercury, the planet of wisdom and communication. And then to go along with all of this, the Annunciation is the feast that's tomorrow. And this is part of what I was talking about over the weekend, because there's this very strong connection between Venus as the morning star and the Virgin Mary in Christianity. But let's look to Mercury, seeing as that is where we are now. Now, Mercury has this very interesting association really with the number 3 and pi. And 3 and pi are actually directly connected too. So I'll talk about that shortly. Now, one of the ways in which you see the number 3 with Mercury is in what's known as its spin-orbit resonance. So for 3 spins upon its axis, and we can look upon that as being it's 58 and 2/3 days, and that's our Earth days that we're looking at there. So it's 176 of our Earth days in 3 of its spins. Whereas if we look at its orbital period, it does 2 orbits in the same amount of time, and this is like really, really accurate. It's one of the most accurate cosmological geometries that there is. So 88 days is the amount of time, 88 of our Earth days is the amount of time it takes for Mercury to go around the sun. So 2 of those, again, makes 176 days. Now, I'm going to talk a lot about this particular roundel from the Cosmati pavement in Westminster Abbey, and you'll see why shortly, because in my opinion, this is an image of Mercury. Now, here is the Cosmati pavement. I've been teaching a course about this pavement for the past couple of months. And the next book project that I plan to do is a pattern making book with all of these patterns, or some of them, from the pavement. Now, if you don't know where this is in Westminster Abbey, and it's immediately before the high altar. Behind the high altar and the screen that you can see there in the background is the shrine of Edward the Confessor. Now, this pavement, as you are quite possibly aware, is where the coronations take place of the monarchs of England and then eventually of Britain. So King Charles III was coronated on this pavement just back in 2023 on May the 6th, which incidentally is the precise midpoint between the spring equinox and the summer solstice. Also the feast in the Middle East, or the day associated with Al-Qidr in Islam, who is St. George in Christianity. Now, I could digress there, but I won't. Let's keep with what I'm talking about here. Right, the inner east roundel. This is the one that I'm looking at. So there you can see east at the top there. So that's where the screen and the high altar were that we were just looking at in the photo. Here's the roundel. Now there it is on the pavement. So it's a very important roundel in relation to where the coronation throne sits, because it is quite literally the roundel that is in front of the monarch, because the monarch is facing east as they're crowned. So this is the one that's directly in front of them. So that one there. Right, let's take a look at some of the qualities of the circle, because this is going to help to inform us with what we're looking at in relation to Mercury. Now, if you listened in your maths classes, maybe you did, maybe you didn't, the mathematical relationship that you find in a circle is pi. So if the diameter of the circle is 1 in length, then the circumference is pi, 3.14. It's one of these what are known as irrational numbers. It goes on to an indefinite number of decimal places, not going into any fixed numerical pattern. Now, another way of looking at pi is if we look at a very close rational approximation of pi. Now, when you actually see this, it'll become clearer what I mean by that. The diameter is now divided into 7 units. And if you take that unit and you put it around the circumference, you'll get pretty much, but not quite, 22 divisions. So 22 to 7 is virtually identical to pi to 1. But it's slightly off because the very nature of pi is that it is what's known as an irrational number. So it can't be understood through a rational number like 22 in relation to 7. But it's a very good approximation. And so it's one that you can use, I suppose you could say, in this rational bounded world when building in units. Now, I was saying before about how Mercury is associated with the number 3. Now, this is something that we can also see with pi, because pi, as I mentioned earlier, is very closely related to 3. And this is something, I don't know, it just never seems to be pointed out, but it seems pretty fundamental to me. Here we've got a circle that's been divided into 6. It's really the most natural division of the circle. The radius of the circle goes around the circle 6 times, in the sense that each edge of this hexagon is the same as the length of the radius. So as you can see, the hexagon, the radius, the circle, they're all very interconnected. But if we look at the peripheral measurement of the hexagon in relation to the circle, we find a very clear relationship of pi to 3. So if we were to say that the diameter of this circle is 7, as it is in the circle on the left, then the radius would then obviously be 3.5, half of 7. Now the radius is the same as the edge of the hexagon, so the edge would be 3.5, and this edge would be 3.5 as well. So every 2 edges is 7. Every 2 edges of the hexagon is the same length as the diameter of the circle. So we can say 7, 14, 21. So if we say that the circle on the left is 22 over 7, which equals 3.14, then we can say that the circle on the right is 21 over 7, and 21 divided by 7 is 3. Simple as that. So the relationship of the hexagon to the circle can be understood as being 21 to 22. But of course, for this to work, it has to be a rational approximation of pi. Right, here we are back at the roundel again. Now, the reason why I wanted to show you this is because I want to count the symmetry that we have. And you can see there's a number 1 that I've put in there at the top. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. It's always good to count, to actually openly express these numbers. So the symmetry of this particular roundel has what is that pi relationship. Now, this pi relationship of 22 to 7 is also something that we find within the orbital movement of Mercury as we experience Mercury from Earth. Now, you may have seen me show this particular graphic before. I showed it, I think, in the very first of my lunar sessions back in, oh, that must have been September in 2023, I think. Now, I've divided Mercury's orbital circle, which is that smaller one in the middle. I've divided that up into 22 steps, and you'll see why shortly. The other orbital circle is Earth, as the blue dot there. So if we start moving them around, they begin with an inferior solar conjunction, which is what we're having pretty much at the moment. We're about 3 minutes away from it now. So let's now move off from a conjunction. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Now, why have I used 22 there? Well, if I now carry on to the next inferior solar conjunction, I'm going to go 1, 2, 3, 4, 5, 6, 7. So every new conjunction, every new inferior solar conjunction is 22 plus 7, you could say. So if the orbital movement of Mercury would be 22, then it would be another 7 of those steps, which would lead to the next conjunction. Now, this happens as we go along. So what ends up happening is that there are 22 of these conjunctions in a 7-year period. Now, this is what we see of Mercury from Earth. We see the conjunction cycle. We don't see the orbital period because obviously we're not on Mercury. So what we see is the conjunction cycle. So there's 29 orbital periods that Mercury has in 7 years, but we see it as 22 synodic periods. So if we keep that going, here's the next one, which is another synodic period later, and the next. And we'll just keep on going like this. And then back up to where we started. So Mercury's synodic period, as I said, one conjunction to the next. That's 116 of our Earth days. Now, really interestingly, if you take that number 22, which is occurring with Mercury as we experience Mercury, and you multiply it by 4, you get 88. And that is the amount of our Earth days that Mercury's orbital period actually takes place over. So the pi-ness of Mercury is directly implicated by the period of time you get in one spin of Earth upon its axis, one day. So it's a fascinating connection. It's not just this isolated thing going on its own. This is happening in relation to our experience of Mercury from our own planet. Now, by multiplying the 22 by 4 to get the 88 days of the orbital period, then obviously we have to do the same thing with that extra bit. So those 7 steps, we multiply them by 4 and we get 28. And that's the amount of days after the orbital period of Mercury has been defined. We do another 28 days, and that gives us altogether the 116 days that are in that particular relationship. Now, if we take that synodic period and we multiply it by 22, which is the amount of synodic periods I showed you here, what we get is 2,552 days, obviously our Earth days. Now, if we multiply that by the Earth year, 2552 divided by the Earth year, 365 and a quarter, you end up getting, let's call it 7, 6.99. It's 99.8% the same as 7. So 22 synodic periods in 7 years. Now, looking at the red color of the stone in the middle, the color associated with Mercury is red. That's cinnabar, as you can see in the stone here. Now, the stone in the pavement isn't cinnabar, but it's been known since Roman times. It's very poisonous, so perhaps this would be a reason to not have it actually on the pavement. But the color of Mercury, that red color, is what you find within this particular roundel. So there's another apparent Mercurial connection. But the thing that's particularly interesting about this roundel, and the thing that really won me over to the idea that it is Mercury, is if you look at how irregular that circle has been placed. Now, it's not even an ideal circle. And as you can see, around this edge here, the mosaic has actually been cut to somehow wedge in this irregular circle that's not been cut to the right shape, or the right, I suppose, size, you could say, and it's not an ideal circle. Now, something, if you're aware of my work, you'll be aware that I'm very interested in what might be described as well-executed irregularities. I talk about one particular irregularity a lot in my book, The Cosmos in Stone, in relation to some of the chapter houses of the cathedrals that I've been looking at. Now, York Minster is the one that really stands out, and it's to do with the chapter house on the north side. As you can see here, the chapter house is skewed in its orientation in relation to the whole of the rest of the cathedral church. Even the vestibule that leads into it is really in line with the cathedral church, but it's just that chapter house that isn't. Now, what I say in my book is that this amazing diagram envisioned by John Michell sometime around 1969, 1970, this appears to be old knowledge, and it appears to be used in 3 of the cathedrals. And the thing about the irregularity is that it's actually a lunar angle. So if we put in the diagram of the Earth and the moon is the chapter house, and you see that skew in the architecture is actually the same as what's called the inclination of the moon, which is 5.15 degrees. Now this, again, this is old knowledge. This is known to have been discovered in, I think, the 3rd century BC by Hipparchus. He worked it out through looking at the positions of eclipses. And he managed to work out from that that there would be this roughly 5-degree angle of inclination. What the inclination is the difference between the orbital plane of Earth around the Sun, which is the horizontal line, in relation to the orbital plane of the Moon around the Earth. And this is the angle that you find with the York Chapter House. So it really reinforces the idea that that diagram of the Earth and the Moon is used. Now, Wales, which of course is the main subject of my book, the chapter house at Wales doesn't have the skew, but the vestibule that leads into the chapter house does. So here we have this, again, completely unnecessary, very well executed irregularity. Considering all of the very well proportioned work all around it, it would seem a bit odd if they suddenly bodged something just at the last minute with this doorway. There's no reason for it to have that skew. But again, it's a 5-degree angle, just over 5 degrees. And there's looking at the vault from down below. Now, the other cathedral that I look at is Southwell, and that also appears to have this angle within the chapter house. But this time, it's not so much, well, not a really obvious irregularity. It's just a door that is off-center. The door that leads in is off-center. Now, here's how the Earth-Moon diagram works with this one. Now, here is the doorway. This pillar here is actually at the golden section of the wall. If we think of the wall as going from here to here, this is at, well, it's actually 13/8, which is a Fibonacci approximation of the golden ratio. So this picks up the golden ratio, but it also picks up the lunar angle as well. Because if you draw a line to just about an inch off the center of that pillar, you get the very precise lunar angle. So there with the horizontal line, you have, I suppose you could say, the horizontal axis or the east-west axis of the chapter house. But then if you draw a line to, like I say, just about an inch off the center of that pillar, it gives you the 5.15 degree angle. Now it's always around the doorway, this entry into the chapter house where this skew seems to be used. So that in itself has quite an interesting symbolic connotation to it. Now, are we to believe that this irregular circle is the result of bad workmanship? I mean, I do wood parquetry, so I'll do, say, Islamic patterns in wood parquetry and other patterns. So it's not obviously the same material as this, but it's very much the same mentality. You're cutting shapes and fitting them together. And I ask myself, would I do something like this? Would I get something that isn't really cut to the right size or not even really the right shape? And would I go to the trouble of actually bodging the rest of my pattern just to somehow squeeze this irregular shape in? Well, of course I wouldn't. I mean, it's an absolutely ridiculous idea to suggest that any artist would consciously do this on purpose. Now, I have a good friend who's a very good stoneworker, and in fact, he did the first conservation survey on the Cosmati pavement, a brilliant master craftsman called Nick Durnan. And I said to him, would you be able to cut a stone into a correct circle the same size? He said, well, yeah, of course I would. And of course he would. It's obvious. So why on earth is this circle irregular? And why have these mosaic pieces been cut? Now, something to say first off is that all of these mosaic pieces around here, around the edge, so the squares and these triangles here, they're all original. They're all from the Cosmati pavement in the mid-1200s. But the roundel in the middle is said to have come later by the conservators and the art historians who've looked at it. Now, this is also the case with all four of these roundels here. And what they have in them is a bit out of the ordinary when you look at, Cosmati pavements in Italy. You don't really have something where you have a black dot in the middle or a seven-sided shape, a heptagon, or an irregularly placed hexagon, as we see here. So what's suggested is that those were placed perhaps maybe the first half of the 1600s. Now, the interesting thing that we have here is that it's at the very beginning of the 1600s when Johannes Kepler first starts to talk about the irregular elliptical orbits of the planets. So Mercury is famously really, really very out of the ordinary in what's known as its eccentricity. That's its irregular elliptical orbit around the sun. So, in my opinion, I think this is on purpose. It's a well executed irregularity to actually put in something that is mercurial, to actually embody what the planet does on the pavement itself. Now, if you saw my last session that I did of these, which was in mid-December for the solstitial full moon, you may remember that I showed this as well. In the work of Richard Foster, who wrote a really excellent book called Patterns of Thought, which is about the symbolism of the Cosmati pavement, he comes out with what I think is a very good theory, and that is that these two roundels being pointed at here are the sun and the moon. The sun, particularly, that is the alchemical glyph of the sun, a circle with a dot in the middle. The moon has an association with the number seven because each quarter of its cycle is around about 7 days, just a little bit more than 7 days, but seven is the nearest whole number, and it's very much a number associated with the moon. Now, this is a very common theme you find in so many traditions where you have the sun on one side and the moon on the other, and then very often a middle path of ascent between them. Now, I talked about this in that last session. In the Christian tradition, the cross of Christ has the sun on one side and the moon on the other. Of course, the sun is the form of day, the moon is the form of night. And so, in the middle axis of the cross, what you could say where day and night meet, that is twilight, and that is where we see the planet Venus either rising as the morning star or setting as the evening star. And so you have this symbolism of Christ as the bright morning star, but he's also, when he descends into the underworld, you could say that he's like the evening star descending into the underworld before he then rises as the morning star in the east. And so that's what's happening with the middle axis of the cross. And this also ties in with what you could describe as serpentine symbolism, because Christ's ascent is associated with Moses raising the serpent in the wilderness. Now, if we look at the sun on one side and the moon on the other, what we can then see is what is in between them. Now, here is the caduceus of Mercury, Mercury's staff. Mercury found two serpents in battle. So he got a stick and he separated them, and then they wound around the stick. And so you have the introduction of this third element, which therefore allows conflicting opposites to enter into relationship. Now, symbolically, these two serpents are often looked upon as sun and moon, the two opposite sides, which need to have that middle place where they can join in relationship. Now, Mercury will often be depicted with his caduceus, as it's called, and there again you have the sun and the moon, and there he is in between these two people with their swords, bringing about this balance between them. Here's another one, and again you can see the sun and the moon being held by the male and female figures at the bottom. Mercury, you could say, is the master of polarities. He's the one who brings these two into communication, into relationship. Now, you also see something very similar in what would be called Kundalini. Two serpents. One serpent is sun, one serpent is moon, and symbolically they work their way up the body to the crown of the head. So if we have the sun on one side and the moon on the other, directly in front of the monarch, in the middle, we have Mercury. Now, finally, let's just look at all of this in relation to the actual ritual that goes on. The coronation chair has this symbolism of heaven above and earth below, with the human body as the ladder that leads between the two of them. Now, if you think about it, when the monarch is coronated, they have the circular crown above, which would be an image of heaven. The circle is heaven, the square is earth. So you have the circular crown above, and then you have the cuboid stone below. As well as the square, the cube is also a symbol of the earth. So you have heaven above and earth below. And then the body of the monarch is the ladder that joins them. Now, just to confirm this, the cuboid stone, which is usually called the stone of destiny, another of its names is actually Jacob's pillow, which is from the story of Jacob's ladder, where Jacob has the dream of the ladder stretching between heaven and earth with angels ascending and descending. So this idea of the body as being a ladder and the two serpents winding their way up the ladder is what we can see symbolically within the coronation ceremony. Okay, I hope you enjoyed that talk. Let's start drawing for those who want to draw. Now I shall stop sharing my screen and say hello. Right, I shall spotlight myself. Um, I probably have to do this. Oh, that's better. Okay. I couldn't see how to spotlight myself for a second. Right. Hello, everyone. Welcome to this session. It's really good to have you here. I hope you enjoyed that talk. I really enjoyed putting it together. There is so much interesting symbolism just sitting there in front of us if we open up the capacity that we have to see it. And this is one of the things about, I suppose, a culture, if it loses touch with its tradition, as long as we hold on to the forms themselves, then there may come a time when people perhaps develop the capacity to see symbolism again, and then immediately we can wake up to it. So, for instance, that thing with the coronation chair, it's not, you don't see that written anywhere, but you can see very clearly if you look through a symbolic state of or way of seeing that you can see that that's there. The symbolism is just there. And it's even there, as I say, in the name, where you have Jacob's pillow. That's the name of the stone. Right, I shall switch on my drawing camera and I'm going to get us to draw, well, to divide a circle into 22. I actually did this division, as I mentioned earlier, in the very first lunar session that I did. So I shall get us to do that same division. We'll use a slightly funny measurement from the ruler because I want us to fit all the circles on the page. So I've sort of used, it'll be a very precise measure that I'll give you that you'll need to use. Now, as ever, I always use inches, and I'm sort of 1 over in relation to that from John Michel because all of the things that he's really pointed out that suggests that imperial measure derives from, I suppose, naturally existing units of measure. Now, what I'm going to get us to do is to draw the outer part of that roundel. So I'll just get you going on it. It takes a bit of a while to do, so I'll just get you to draw some of it. This is the most outer part of that Mercury roundel where we have these 22 squares, the ones that that I counted. Now, the circles in the background that you can see, they're the what we use to divide up. I thought I'd put all the circles in because it just makes for quite a nice mandala. And we'll put a few extra circles in as well, so you can put in these small triangles. So like I say, I'll get you started with it, and I'll do enough for you to then carry it on and finish it if you want to. Right, let's begin with the radial measurement. Now, I'm actually going to divide the circle in the middle. So we want 3.5 inches as the radial measurement. That's the middle of that band. So that's what I want us to go with. You can, well, if you were to use 4 inches, then it's sort of a bit of an easier unit you take from the ruler, but go with 3.5 inches because then all these circles will fit on the page. So it just looks a bit nicer. Now this gives us a circle with a diameter of 7, so it fits in also with the whole 22/7 relationship that I've been showing you. Now this particular division of the circle we're going to do will first into 11 and then into 22. The description of it that I've seen comes from Albrecht Dürer, and it's a rational unit of the diameter. It's a very close approximation. It's not exact, but it's very close. So it's the one that's worth using. Now, what he says is that if you take half of the radius and you then increase that half of the radius by 1/8, that gives you this very close approximation to 1/11 of the circle. Now, just take it from me, what you need to do is to go down to 2 inches, but we're going to go a tiny bit lower than 2 inches. So I'm actually going to go literally half a 16th down. Now, bear with me on this one. I know it's a bit of an obscure measure, but it just means we can have a circle that's 7 inches, 22 inches, so it's quite nice to use. So as you can see, these little increments here are 16ths, and I'm literally just going to do half of a 16th below 2 inches. For my right. Okay, I'm going to go to the top of the circle. And I'm going to draw a circle like so. Now this is approximately very nearly 1/11th of the circle. So I'm going to go into that intersection to draw another circle. Now, because there is this thing that can be described as oh, I've forgotten the term now. I might remember it in a second. The build-up of inaccuracy. If you have a tiny inaccuracy, but you then repeat that inaccuracy several times, accumulated error, that's it. That's the word I was trying to think of. Accumulated error. Sounds a bit like what you might say in a Roman Catholic confessional box. Um, Full of accumulated error, Father. I am from a Roman Catholic upbringing, but a good one. Now, having gone around, because of this possibility of accumulated error, I'm actually, having got halfway around, I'm now going to begin from this way here, because if there is any accumulated error, it will halve the amount of it by coming up here and working from here. Now, fingers crossed this will work out. I'm only human, but you always wonder if this is going to work. If it doesn't, I shall just embrace my humanity. Oh, nearly. As good as, just a tiny bit off. So there we have 11. Now, we could, if we wanted to, put a line through here and then begin to do the same thing from here. But I think I'm just going to put lines through all of these vesicas here, because that gives us the half division of each of these 11ths. And we are going to need those lines anyway. Now I'm actually going to go all the way through, just to make sure it's accurate. I'm going to go all the way through to the opposite point, even though I'm only actually going to be drawing here. Oh, actually, I want to do things, I want to do the lines a little bit lighter than that, actually, because these are construction lines, so we don't want them too heavy. So I'll be pressing a bit more lightly than that first one. Yeah, after the procession around the cathedral on Saturday, I didn't get to sleep for till about 3 in the morning. It really woke me up. And Guy, my co-host, he had some rather amazing dreams as well. So processing around a cathedral singing Gregorian chants is a good idea. And we are planning, we are hoping to do more events like that. So do keep your eyes out for what I send on my mailing list. Guy sang some Hildegard chant as well, which was rather wonderful.
I was there and it was absolutely beautiful.
Good. Yeah, it's a lovely evening.
Mm.
Right, so as you can see, you've now got these halfway points between each 11th. So providing you've still got your compasses at that measure, which I assume you have, you can now go to each one of these points where it goes through that circle that we've drawn. Yes, processions around cathedrals. I think they're like blood circulating around the body, taking the spirit around the body, the breath. So I also like the number 22 because I was 22 years old when I had my spiritual awakening. So no wonder I became a geometer. So as you can probably see, these very slim overlaps of circumferences here, these sort of slim leaf shapes, where they meet the circumference of our 3.5 inch circle, um, they are the 22 divisions. Now, before we start working with them, we need to put in a couple of more circumferences, which are actually going to be this one and this one. Now, again, they're rational units. And we'll also put other circumferences in there as well. We're going to put a total of 5 in. 1, 2, 3, 4, 5. The middle one of those 5 is the one we already have. But this will help us to draw the various shapes we need. I'll bring that back. Right, the two strong lines that we need to get that banding are 3 inches and 4 inches. So the band is going to be 1 inch. And I suppose that's inevitable because if we've got 7 here and 22 here, then each one of these squares is 1 inch, as you can see. So inevitably, that's what we're going to have. So I think we'll do the strong lines first, and then we can do the sort of weaker construction lines. I'm going to do this line, as I say, more. This is a sort of final line. We want it to be strong. That's 3 inch radius. You're going to dampen down this line a bit. So having done the 3 inch radius circle, I'm now going to do the 4 inch radius. Yeah, I'm drawing in both directions here. We had to decide which direction we were going to process around the cathedral. And I immediately felt it should be anti-clockwise because that's the movement of the stars. And Stella Maris, which is one of the titles of the Virgin Mary, the Stella Maris is the celestial North Pole. So that's the fixed point that all the stars move around anti-clockwise. But yeah, clockwise and anti-clockwise, you have them both in various different religious traditions. Muslims go anti-clockwise around the Kaaba in emulation of the stars. So the Kaaba is like the earthly pole that reflects the celestial pole. Whereas, say, Buddhists, I think, and Hindus as well go clockwise. Of course, if you were turning something around, um, if you look from above, it would be going in one direction, but if you look from below, it would be going in the opposite direction. So when you turn something around, it's going both directions at the same time, even though it's only turning in one direction. Try and get your head around that. Even though there's two, there is only one. Right, I'm now going to do fainter lines that are like that middle faint line there. So these are construction lines, don't need to be too strong. And these will just be in between the middle and the side ones. So the first one I'm going to do is 3¼ inches. And the other one is 3¾ inches. So, just the halfway between what we have. Hello, Jane. Yeah, the second radius is 3 3/4 inches. I'll show you all of them together now because they all sort of fall on the ruler in 1/4 inch differences. So if that first stronger circumference that we did was 3 inches, and then we just mark 3 1/4, we already have 3 1/2, and then we add 3 3/4, and then that 4 inch one is again the other larger circle that we did. I'll leave the ruler here just for a second so you can sort of keep an eye on all those different measurements. Right, we're going to need to put a few more lines in, and then we can start drawing the squares. Now you see this sort of slim leaf shape here.
Tom, the lighting on your screen is not so good for your faint lines. It's not as clear as it often is. I don't know if I don't know. They're very, very faint because I think it's to
Yeah.
do with the light.
Yeah, it's difficult to know how it is on everyone else's screen because
Yeah,
it's
sure.
fine on my screen, but perhaps if you turned up the brightness on your screen a bit, that might make
Okay, thank you.
Right, as you can see, I've put a line in here and here. So it's within this slim leaf shape, this one here. That's where I'm putting these new lines in. Right, I'm going to go to a stronger line and bit of a blunt pencil as well. This is really just because I need to, I suppose, variate the thickness of the lines so you can see what's going on. But you don't need to do that. You don't need to have a blunt pencil, but these lines are now going to be stronger lines. Now, the way that we draw the squares, and go easy with them because they can quite easily become, let's say, a bit more diamond shaped and not so square shaped. So it might even be worth them standing up above your work, possibly. Now, I'll draw it in and then I'll describe to you what it's used. Now, the lines that we just drew in, where they cross the strong circumferences, the 3-inch and the 4-inch circumferences, that's where we get these two corners of the square. Now, remember these very slim petals, very, very slim leaf shapes, which is what give us the original division of that first circle. That's where it's the top of those leaf shapes, which is what gives us the other two corners of the square. Now, because we're on a curve, obviously these squares, even though they are touching corner to corner, their orientation is going to be slightly different. And this is the way that to actually get a sort of curved line on a Cosmati design. Oh, it is possible to cut them, like when Nick Dernan, who I mentioned earlier, when he did a Cosmati pavement in Buckfast Abbey, someone cut all of the shapes for him and then he put it together. And they were all cut very slightly, I think, off their regular shapes so they could fit around curves. Right, here's the next one. Right, I'll leave it at 7, but obviously you just keep going all the way around. Now I'll show you the other little bits. One thing to be aware of is that these Cosmati drawings are always sort of much more, I suppose you could say, accurate than what you see on the Cosmati pavement. There's a real organicness to the mosaic themselves. So what we're doing is a sort of ideal version of what's on the pavement. But if anything, part of the charm and the beauty of the Cosmati pavement is that all the pieces are, you know, a little bit irregular. The whole thing is quite organic, so it's particularly beautiful. The later Cosmati pavements were sawn, so they were much more sort of accurate, and they obviously have beauty as well. But there's something I particularly like about the earlier ones that were cut with what's called a hammer and hardy, so like a sort of a chisel hammer. Right, this is where these intermediate lines come in that we did, like the 3¼ inch and the 3¾ inch circumferences. So that's how I'm getting these two positions here for drawing this line. That's a 3¾ inch circle. Now there might need to be, so for instance here, we don't have a line here, but we can obviously just put that in very easily. So this will happen a bit. There'll be the odd time when you need to add an extra line to find where you need to be. Now, a similar thing applies to shape below. So this, I mean, as you can see, would technically need to be a slightly different size and shape of triangle because it's fitting within a smaller diameter. Or sorry, a smaller circumference rather is what I meant. Now here again, I need to add another line like so, and then that'll give me this point to work from. So all of the points you need are there. You might just need to add a few more lines. So you keep progressing like this, and that will give you that outer part of the roundel. Now I'm going to share my screen again, and we can just take a quick look at the roundel again. Now, if you look at those little triangles that I was just drawing there, see how sort of irregular they are. And as I say, that's just part of the beauty of the pavement. The eye sort of knows what it's seeing. The eye corrects things. And this is similar perhaps when you see flowers in the garden. They all have good approximations of these various geometric symmetries, but there's a bit more of a flow and a movement. So it's not very rigid and absolutely accurate. And there is a certain beauty to that. There's obviously a beauty to accurate forms as well, but both have their place. Right, to finish off, ladies and gentlemen, thanks very much for coming to this session. But I want to tell you about my next online course, and this is actually going to be about my book, The Cosmos in Stone. It'll happen during May, June, and July. There'll be a couple of sessions in May and then a bit of a gap because I've got so much stuff on. And then the remaining classes from June the 21st, the summer solstice, will run onwards. In fact, the June the 21st session might even be a sort of public session as well, because I'm actually going to be with a big group of geometry friends, and I might sort of give them the session live while also giving the session online. There's a group of us who always meet around the summer solstice, as you'd expect. So do feel free to come on this course. It's going to be on my website very soon. It might even be on there now, but very soon, if not. Okay, everyone, good luck with finishing that off. I hope you've enjoyed the session. I've really enjoyed it. Mercury, I was concerned because he's a bit of a trickster, Mercury. So I was concerned that things may go a bit wrong. So there were a few things that went a bit funny in the lead up to the session, but thankfully it's worked out. And it's been really quite an amazing few days for cosmological goings on. The equinox on the 20th, Venus conjunction on the 23rd, Mercury now, and then of course the Annunciation tomorrow. And the symbolism of the Virgin Mary very closely accords with the Venusian symbolism and the equinoctial symbolism, because the Annunciation, the 25th of March, used to be the actual spring equinox in the old Roman calendar. Right, I could go on, but it's time to go. So thank you very much for coming, and I shall hope to see you all again at some other point. So have a good day tomorrow, and I hope you finish off drawing and enjoy it. Okay, goodbye, everyone.
Bye, thank you, Tom.
Thank you, Tom.
Goodbye. Thank you.
Bye.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you, Tom. Thank you.